There we go. All right. So again, we're starting chapter 8 today. Chapter 8 covers right triangles and trigonometry. And we're going to start with actually section 2 of this chapter, which is the Pythagorean theorem. This is a good section for us to do this week while we're still virtual learning, because you guys all have at least a passing familiarity with Pythagorean theorem from having taken Algebra 1 and from middle school. So just as a reminder, the Pythagorean theorem reads, in any right triangle ABC, and it does only apply to right triangles, with side lengths A, B, and C as shown in the picture on the right, the sum of the squares of the lengths of the legs must equal the square of the length of the hypotenuse. Now that's a really fancy way of saying that in any right triangle, if C is the hypotenuse, then A squared plus B squared equals C squared. Okay? So your two legs, A and B, are interchangeable. It doesn't matter which leg you call A, which leg you call B. What's important is that everybody knows how to find the hypotenuse, where we take the right angle, we go across the triangle, and that number has to be the hypotenuse. That has to be the longest side of the triangle because it's opposite the largest angle in the triangle. So the key to Pythagorean theorem is always being able to correctly identify the hypotenuse. Okay, and then we're doing A squared plus B squared equals C squared. That is our equation for Pythagorean theorem, which again, everybody should be relatively familiar with from their time in Algebra 1 and their time in middle school. So what we're doing today, what we're focused on today, is solving for missing side lengths, which is the skill you have done before, which again should make for a nice first day back after winter break. So we're going to jump right in here. You will need your yellow calculator, so please make sure you've got that handy. Here is an example of what you're going to be needing to do today. This is probably the easiest of the examples. Find the length of the side labeled x in the right triangle. Give your answer both as a reduced root and as a decimal rounded to the nearest hundredth. Okay, so what we're going to do, first thing we need to do is figure out whether our missing side is a leg or a hypotenuse. So in the chat, please, would you tell me, is x in this particular picture a leg or the hypotenuse? Is it the leg or a hypotenuse? So let's drop that in the chat for me. Okay, very good, very good, very good. Again, we figure out which one is C first. We need to know what the hypotenuse is. So we go to find the right angle. We go across the triangle from the right angle. That one is our C, our hypotenuse. The other two, it does not matter at all which one is A and which one is B. Those are your legs. So we're going to set up A squared plus B squared equals C squared. Okay? So A is 6, B is 15, and we don't know C. C is our variable. Okay? Plug those in. 6 squared plus 15 squared equals x squared. And we're going to solve this equation. So 6 squared would be 36. 15 squared would be 225. We add those together, and we get x squared is 261, I think. I'm going to quickly check that, make sure I'm not screwing it up in my head because it's early. Yep, 261, as he almost drops the calculator. Okay, 261 is x squared. So here's your next question for the chat. How do we solve that equation for x? We have x squared equals 261. What do we do next? Type in the chat. What do we do next? Yep, nailed it. We take the square root of 261. So x is going to be the square root of 261. Now that may or may not be the reduced root. So what we do is we actually type that into the calculator, take the square root of 261. As it turns out, 261 is 9 times 29. The square root of 9 is 3. So the reduced root answer would be 3 root 29 meters. Okay, that would be our reduced root answer, would be 3 root 29. So remember that when we're reducing a root, what we're really doing is we are breaking that root up into two roots. One of those two roots should be a perfect square, a number that has a square root, and the other should be whatever's left over when we divide the original number by our perfect square. Okay, and we'll see a couple more examples of this. So there's the reduced root, okay? So that's our reduced root answer is 3 root 29. Now, if we also want to give the answer as a decimal. So to convert into the decimal, we take that answer, which should be written on our calculator right now, and we hit the convert button on the calculator. Okay, so right above enter is the double arrow button. We're going to press that button, and that will tell us that x is approximately 16.155. Now, I'm only looking at the first 3 digits because rounding to the nearest hundredth would mean that I'm looking at that third digit to tell me whether I'm supposed to round that number up or round that number down. Since the third digit is a 5, that tells me I need to round the second digit up, and my approximate answer would be 16.16 meters, rounded to the nearest hundredth. Okay, so my decimal answer, properly rounded, is 16.16 meters. Okay, so that is the basic skill that we're going to be doing today. Now, there aren't a whole lot of tricks that can come up, but we're going to look at a few examples of this so that we can see every little detail. Any questions before we advance? You can type them in chat. You can unmute and ask. Any questions before we advance? Going once. Okay. Nobody's jumping at the opportunity, so we will move on to the next example. Okay, find the length of the side labeled x in the right triangle. Give your answer both as a reduced root and as a decimal rounded to the nearest hundredth. Now, here, we need to start off by asking yourself, the side that we're trying to find, is it the hypotenuse or is it a leg? So you need to start off by finding the hypotenuse. Again, that involves going to the right angle, going across the triangle. That number is your C value. That is your hypotenuse. So we know the hypotenuse this time, which is going to make the problem a little bit different, not a lot different, which means our variable is one of the legs and 9 is the other leg. So we'll call x the A, and we'll call 9 B. The hypotenuse is 11. So we have our variable is one of the legs, our other leg is 9 feet, our hypotenuse is 11 feet. The work is still pretty much the same. The solving is going to be a little bit different. We're still going to plug into a squared plus b squared equals c squared. But this time we end up with the equation x squared plus 9 squared equals 11 squared. So last time, on the last example, we pretty much simplified one whole side of the equation because there were no variable. Well, here we're going to have to solve instead. So we have x squared plus 81 equals 121. And then we get x squared by itself, so we subtract 81 from each side, which gives us x squared equals 40, which means that x is the square root of 40. Now, Again, the 40 is not a perfect square. It does not have an exact answer, so we need to reduce that root. Remember that when we reduce a root, we ask ourselves, what is the biggest perfect square that divides 40 evenly? Okay, when I say perfect squares, I'm talking about numbers that have square roots. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Those numbers, okay? And there's more of them, but I'm stopping at 10 squared. So we ask ourselves, what is the biggest perfect square, and you can type the answer in the chat, that divides 40 evenly? What is the biggest number from that list that divides 40 evenly? Good, 4 times 10, perfect. So the root 40 breaks into a root 4 and a root 10. We break it up into two separate roots. One has a square root, one does not. The square root of 4 is 2. So x is 2 times the square root of 10 feet. That is our reduced root answer. Then we just need to convert that. So we hit our convert button on the calculator to root 10, and we convert it to a decimal. We are looking at the decimal 6.324. Again, the only reason we're looking at that third digit is to tell us what to do with the second digit. 4 is less than 5, so that would mean that we would round down, indicating that we leave it as 6.32 feet. Okay, that's it. That's pretty much it, folks. That is pretty much the skill we're working through today. Now, we are going to go through 2 more examples here before we call it a day, but there really are not any tricks to this. These are straightforward problems. The big thing is that you need to make sure you're reading the problem, because it won't always ask you just to find x. Sometimes it'll ask you to do something with x, okay? So, again, any questions before we advance? Any questions so far? There's pretty much only 2 problem types. We've had 1 example of each. Nobody's jumping at the opportunity again. And again, you can unmute and ask. You can type it in the chat. Any questions before we advance? If you guys are anything like me, I'm really looking forward to seeing you guys in class in person so that I can get more questions out of you. Because I'm sure some of you have them, just don't want to ask online. But that's okay. Okay, all right. So let's go on. We'll do the 3rd and 4th examples here. Starting with example 3. Again, same directions. Find the length of the side labeled x in the right triangle. Give your answer both as a reduced root and as a decimal rounded to the nearest hundredth. So what I want you to do, I'm going to give you about 45 seconds here, or maybe more, like a minute. And I want you to go ahead and do this problem. Okay, do this on paper. Do it on your own. I'm giving you a 45-second head start. Get an answer. Okay, show your work, because you're going to have to show your work on your homework. Work your way through this problem, please. I'm just going to answer an email real quick. Okay, hopefully we've had enough time here. Again, the key is we find the right angle, we go across, and we locate the hypotenuse first so that we make sure we get the correct number or variable labeled with that C value. In this case, we're finding C. The other two sides, it does not matter at all which one you call A and which one you call B. So for instance, we could use A is 17, B is 7, and again, C is what we're trying to find. Now, A and B are interchangeable. If you decided that A was 7 and B was 17, that does not matter. It should make absolutely no difference at all in the problem, okay? We're doing A squared plus B squared equals C squared. So that would be 17 squared plus 7 squared equals X squared. You managed to use probably the two numbers that most of you hate the most in terms of perfect squares. 17 squared is 289. 7 squared is 49. Add those together. We're looking at 338 is equal to X squared, which means that X is the square root of 338. Now, 338 is divisible by the perfect square 169. It is 169 times 2. Okay, it's 169 times 2. And 169, the square root of 169 is 13. So you should have 13 root 2. And this time, it doesn't tell us what the units are, so we have to use the generic units. Okay, I can't see everybody, but thumbs up, thumbs down. How did we do here? Did okay? All right, good deal. Now again, your calculator can do that reduction for you, so you don't necessarily have to notice that that's divisible by 169, because if you type it in your yellow calculator should reduce it for you to 13 root 2. But that's how that works. It gets broken up into two roots, one that is a perfect square, one that is not. So then we convert that into a decimal. Again, you're just going to hit the convert button on your calculator. 18.384. And again, the only reason I'm writing the third digit down is so we can look to see for rounding. 4 is less than 5, which means that we would round down. And our approximate answer would be 18.38 units. Again, reduced root and decimal answer. Okay? All right, one example to go, and then we'll call it a day here. Anybody have any questions before we advance to the last question? Okay. So last one. Again, I'm going to give you some time. I'd like you to do this problem on your own. Okay, notice that the directions are not the same, so make sure you're reading the problem. This is a big SAT skill, which is, again, you guys' college graduation or high school graduation test. You have to get a certain score on the SAT, so make sure you're reading the problems so that you don't screw that up. Please solve this problem. I'm going to give you a little over a minute here to get started. Work your way through this problem. And I'm giving you time once again. Time once again. All right. So the big thing to notice here is that you're not doing exactly the same thing, okay? It doesn't say find the length of the missing side. Okay, you got to make sure you're reading those directions and that you are doing what the problem is asking you to do. Now you are still going to have to find x first. So find x first and then use x to answer the question. This example also has a somewhat fortuitous wrinkle to it in terms of the number you get for x. How are we doing on time? Are we good to go? Is anybody still working hard and needs more time before I start going through this? You can type that in the chat. Everybody okay? We're good? All right. For the starters here, same basic approach. We need to locate the hypotenuse. So we go to the right angle, we go across the triangle. That is our hypotenuse. Doesn't matter on the other two which one we call A and which one we call B. So I'm going to use my variable for A. I'm going to use 16 for B, and I'm going to use 25 for C. A squared plus B squared equals C squared, which would be x squared plus 16 squared equals 25 squared. Now, 16 squared is 256, and 25 squared is 625. That's not right, is it? Something's wrong there. What'd I do wrong? Maybe nothing. No, that's right. I think. Hold on. My brain is shorting out. Give me a second. Yeah, okay, we're good there. Then we subtract 256 from each side of the equation. Maybe not as fortuitous as I thought it was. So 625 minus 256, x squared is equal to 369. Take the square root of 369. Which is 9 times 41, or 3 root 41. However, the problem tells us that our answer is going to be rounded to the nearest hundredth, which means we don't really need the reduced root answer this time. We only need the decimal. So we hit the convert button and we round that answer 19.209. That 9 tells us to round the 0 up to a 1, or 19.21 inches for x. Okay, so there's my x value. Now this is a very standard SAT style question. Okay, remember that most of the SAT is multiple choice. Not all of it, but most of it is multiple choice. And I 100% guarantee you that on the SAT, one of the answers would be 19.21 or 19.2, depending on how they tell you to round. But does that number answer the question? Just shake your head on your camera. No, it does not. That is a side length. That is not what the question asks you to do. It asks you to find the perimeter. So how do we find the perimeter? Anybody? Type it in the chat. You can unmute and tell me. How do you find the perimeter of a triangle? Or any shape, really. Yep, you add up all the sides. So the perimeter, which we'll call it P, would be 16 plus 25 plus 19.21. And I'm going to change my equals to an approximate only because I'm using a rounded answer. But again, that's not a big deal if you just use equals. We have an answer of 60.21 inches is the official answer to this question. So again, please be cautious. Make sure you're reading the problems. Don't just find the value of x and throw down the answer. Okay. So let's see here. That does it for our lesson on here. So hit stop on the recording.